Yo, what up? Hello, I'm SolarLone. Welcome to my stream. How's everything going? Hope everything's going well. Hold on. Let's see here. What am I looking for? Brain not working. All right. There we go. Okay. So, yes, welcome. Welcome to the stream. I'm SolarLone. I'm an independent game developer. I'm the creator of Master Plan. I'm the creator of Tetra 3D. Yeah. 10 commented. He said, I'm going to bed, so not gonna be in time for the stream, but have a nice coding session. Thank you very much. Yeah, so today I thought, I said yesterday I was gonna do some master plan work. I don't feel particularly up for it. I'm like, maybe, I don't know. So we'll see. I kind of want to like get back to this motion graphics thing. It feels like some projects get into my mind and it's just like I need to figure it out kind of thing. Um, so I was thinking about it, and let me get some music going. Let's see here. Is that too loud? No, it shouldn't be too loud. Okay. So I was basically thinking that it might be good. I think this is what Zyko said yesterday. I think this is what he was leaning towards. Is essentially my project, not project. Yeah, not my project, but basically like how I'm defining motion graphics is too literal. Like basically the file that I have on the right side is basically a motion graphic in text. And then my code is structured to turn that into code that, or my code is structured to basically like do things and visualize it. But it's too literal. It's too, exact. It's too like kind of the exact same. So what I'm going to do basically is design a intermediate structure that basically stores this data, and then I can kind of refer to it when I'm actually rendering a shape. So I think that should be a little bit of an easier time. So we'll see if that works. So what this is going to look like is probably like a motion plan. So we have animation duration. It's a float. It can be a float 32, that's fine. We have width and height, which I think I'm going to default that to be 100. Rotation. I'm probably going to redo all these as well, these sequences. This can stay. String to color, that can stay. Okay, so something like this might start off fine. Now the thing that I'm trying to figure out is, it would be nice if I could write this multiple ways. Like it would be nice if I could write, for example, something like this where W is 32, or something like this where W is basically a map that contains different values. Let me take a look at the YAML specification. Mark in a space indicates a complex mapping key. Two diamonds to separate characters from different content. Let's see. Okay. Well, I guess it's not about YAML so much as it's just about me not being specific, right? I want to do that for shorthand. But if I can't do that for shorthand because it's just overly complicated, then it has to be like this. Or could you do like this? No. Nested mappings are not allowed in compact mappings. Well, I mean, this would work, but what I need to do is I would like to... Let me see, hold on. Can I not unmarshal it? Title the decoded. So I mean, I guess I could just turn it into like a map of any to any. No. The internal pointer within a struct is not initialized. The YAML package will initialize it if necessary for unmarshaling the provided data. Okay. Alright, so here's what I'm going to do. Well, maybe we'll just do something like this. Which I guess we could do like this. Strut, byte, this. Let me say, like that. Can I unmarshal here? The YAML node is a map of any to any. Can marshal a sequence? Oh, I see. Okay. So now we might be able to do something like this. Let's see. So shape and path should both exist in this node. Let's see. Invalid receiver type YAML node. Pointer or interface type. I see, so this won't work. Okay, so let's do it like this then. Might work. Okay. So, let's see. So if this works, then we should be able to say it. Scene. I guess we can say motions. Okay, so we have a map of path, which has closed and points, and then also shape. Okay, which is set to path. All right, so then we should be able to say. Motions.get string. Wait. Okay. Get array. Interface is map string interface. Okay, so can convert map string any. Oh, map. I guess we can be string. Interfaces in the YAML. Oh, well then, yeah, if you can do it, then do it. Cool, so that works. All right, so maybe this is what I needed to do. So this will allow me to manually parse the document for setups. So really this isn't a motion list, this is a motions should be okay. what would you call the like the platinum game symbol? Like it's a star. This star, like it's kind of a star, but it's also it's a star, it's a sparkle, it's a twinkle, it's a cross mixed with a star. I don't even know if we need a real star. We'll call it a P star. I guess star could have multiple points, huh? It doesn't necessarily need to have... Oh, I guess a P star and a star are the same. It's just a P star has 4 points. Customizable. Okay, cross. I guess the cross could have multiple lines. Like an asterisk. Okay, so a motion has a shape type, which is a shape type. We have I'm thinking that I could like, let's see. So this contains all the data, then motions. We're gonna take the data and turn it into motions. We could do something like this, where maybe we have different struts. One for the shape definition. If it's a shape, it might not be a shape, though. And if it's not a shape, then we need to have a different data structure for that. So I mean, I'm thinking that this might be a good approach. That we have shape def for shapes. We have maybe like part like spawning def for spawners, something like that. Maybe. All right, so something like this might work. So we have for a shape, shape depth could be any, and then we could have different definitions for different shape types. So we can start off with, say, start off with the polygon, I guess. Let me change the music. So we could do something like this, so width and height can have a sequence associated with it. By default, it's linear. Okay, so this is the idea. So the number of points. Do it like this. Like this, and then we can say maybe that would work. Because then we could say properties. Wait. So we're defining basically the properties that compose the shape definition. Then when we want to pull from this data, when we actually go to visualize the shape, we can go and pull from the owning motions previous definition. Because it may not have a shape. Right, okay. Well, really, all shape definitions are the same. It's just this one determines that it's a polygon. Okay, so then we say okay, so something like this might work. Okay, so something like that should kind of get us where what I'm thinking. Motion definitions. Because not everything will be a shape. Yes. What if we did it like that? We could do it like, whoops, we could do it like that. Because I'm thinking that, like, we may not have, we might have other things. Like, this defines a shape, but you might have something else. But it's never going to go from... Yeah, I don't think it's ever going to do... Like, it's never going to go from a shape, from a motion to a shape. Like, it's never going to go from a shape. I think I'm overcomplicating it, basically. I think I have it set up with an extra layer of... what's the word? An extra layer of, like, diversion that's not necessary, because it's set up so that it can go to, like, multiple levels of emotion. Like, this is a one level, and then the next level could not be a shape, but I can't think of a situation where you would want to go from, like, a path to, like, a spawner. That doesn't make sense. You go from maybe like a rectangle to a triangle or something, but not like anything else. So I think this is probably fine. Yeah, I think it's probably fine to just go straight shape def. So then we use shape defs. Oh, that's why I did that. Okay, I see. So maybe we just say any. Okay. So this is the core idea, and I think this is fine. And then I guess this could be like width and height, and then X and Y as well. Okay. X, Y, width, height, points for a polygon. Excuse me. Okay, so this should kind of get us started. Okay. So now what we want to do, parse, or yeah, scene.motion dot. Okay, cool. So now we say I 0, I is less than that. Data, I plus plus. Or we could just say for okay, so here's one. We could do another one here. Points 5. That's fine. All right. There's a shape that we okay, let's see. Oh, okay. Okay, so here we say shape def dot properties equals start and end. Okay, cool. All right, so this is a good start, I think. There's a slice of tea. Okay, I don't think we have to actually do that. If tips of tree. I guess it's possible that it's a. Well, you wouldn't say. Well, that's yeah. If that tree path. Array. All right. Shape depth. that creates this. Okay, cool. All right. Let's see. Def.hasPath, path data equals def.tree path, path data.array points. Oh, that's why it has array points. All right, so there's my points, my point slice. B should be a slice. All right, so now I should be able to say oh, that won't work for points because they can't be animated. Sad boy hours. Like, in order for this to work, it would have to be a slice. Like, points couldn't be a sequence of anything. It'd have to be a sequence. It would have to be like a sequence of slices. That it like iterates over time. That would be cool if it could work, but I don't want to do that much work. Yeah, that'd be insane. All right, so maybe I need to simplify this then. So maybe shape def, because points it shouldn't be a sequence. So I mean, like, I could make it, I guess I could make it so that these are animated properties specifically, and other properties are not animated. Okay, I guess that's what I'll have to do. All right, something like that. I'm gonna just crib my. I'm just gonna try to resolve that. Slices. Okay, so we got this like that. The X and Y can change over time, so that's why they're not vectors internally. These can be vectors because they don't change. Okay. They don't. I mean, I guess they could tween position could be X and Y. Something like that. markers here. Okay. So path. Okay, so points is now just. Properties points equals points. Okay. 1, 2, 3. There we go. Okay. So if v range theta dot array points chords equals v dot any, so it should be stepping through all of these. Then this is one of them. So we just need to get the first and second. So pinned. Okay. Their ints. Let's see. Is there anything to do this? I feel like there's got to be something like this. Something like what I'm trying to do for YAML. First converts YAML to JSON using GoYAML, and then uses JSON marshal and unmarshal to convert to or from the struct. That might be good, because then I feel like JSON unmarshal why don't I just... Oh, that's right. That's why. Let me look something up here. Looking at this thing called map structure. Let's see. Hold on, let me... Let's see. When decoding from a struct to a map, the squash tag squashes the struct fields into a single map. Convert one arbitrary go type to another to convert to... Okay, let's see. Hmm. What was first name? The last name goes in. Wait. Okay. Okay, so other goes into their stream. So if I'm right, that might help me here, because what I want to do is basically have an optional values. Well, maybe I just need to write a custom unmarshaler. Maybe that is the solution, because I'm like thinking about it. I have to iterate through it somehow. I have to say, okay, well, it's a 5 versus it's a slice, it's an array of 5, of value numbers 5 to 10, versus it is a map containing values and an easing property. So it's like I need more control anyway, so maybe I should just write the unmarshaler and get over it, just kind of deal with it. That might be what I do then. Yeah, okay. All right, I guess that's what I'm gonna do. Shape. Okay, let's try that approach. So you have a shape. Start with that. This data is just a byte, or I guess I'm not. Functions. Okay. It's just this. Okay. Parse. Okay. 15 data. So we don't really need this. Let's see. Is here restart? That's fine. Let's see. Okay, let's see. That's correct. Let's see. Okay, so let's see. Okay. All right, so motion depth is here. Path can be a pointer to a struct. It may or may not exist. It has points, which is slice of float 64s. It has a closed value, which is a boolean. Can I marshal a sequence into? Okay, so it's a sequence of yeah. Can I do a sequence of resolve that vectors? No. Okay. Well, this is just the definition, so it's fine if I think it's fine the way it is. Okay. These can be 64, I guess it's fine. Closed. Let's see. Points. Oh, that's right. Oh, I forgot. I have to have it be in some sort of named structure in order to refer above. And marshal 5 into points, huh? So I have to have a custom marshal. Yeah, that's fine. Well, if I'm gonna do that, if I'm gonna, yeah, I might as well just make these vectors, right? Yeah, okay. This is really shaped up. That's fine. Closed may or may not be there, but if it's not there, it can be false, it's fine. Easing may or may not be there if it's nothing. Let me see, does YAML... You can give it one with default values. Okay. But then how do we know? All right. Well, I have to do this manually anyway. 40 map. Okay, so there's nothing here about the name. Shape type. Well, there may not be a shape type there by default. That's what I should do. Okay. This should help me out a lot. I think. Let's see. One, two, three, 4, 5, 6, 7, 8, 9, 10. Okay, then so this is gonna be closed, and then this is gonna be the result, huh? Yeah. Okay. Is it the value? Points, that's what it was. Zero, 1, 2, 3. 0, 1, 2, 3. The value is the string. There's no way to convert it. Okay. So All right, so I think I'm on the right track here. So we have points. Okay. So, I mean, I guess we could just do it like this, where we just I plus equal 2, because it's the type of content followed by the content itself, the key followed by the value. Okay, and then I guess it could just be I0, I is less than limp node content I plus 2. Just like that. This anymore. Points close. Okay, cool. All right, so then we can switch off of content.value. This can just be case. There we go, and then case closed. Cool. Or parse pool. No, one. So I guess really it would just be key and then value. Like that. Key value. So result that content. Else dot close. What's this? Okay. All right, cool. So this went through. Oh, we haven't actually done anything with this. All right, we could just do this like this. There we go. Beautiful. Okay, all right. Yeah, this is a star, so this really could just be, well, that's fine. We'll leave it like this. But a star could be, we can mathematically create a star. Okay, so points enclosed, that's working for the path. Okay, so path is here. Shape path does not need to exist. It could exist if we have a path, but it doesn't need to. Polygon points. Could exist, but it doesn't need to. Points. There's not that many properties, so I probably could just manually do this. I don't need to overcomplicate it. Points, width, height, x and y are all kind of the same thing in that they're basically this concept. a number range, basically, where the values can be anywhere from, you might have, 1, 2, or more values. There's an easing associated with it. And also, what was there's something else. Values easing. Wasn't there another possibility? Let me see. I nuked it. Oh, wait, no, I didn't. Okay. Snap. Okay. Okay. Points. Number range. Okay. Let's see. Int 5. Why is it not? Oh, it's because it's not a key value pair. Oh. Right. Okay, that's fair enough. Okay, we'll do it like this. I think it's something like this. So we say like values. Map. So then we have content key, string values. Sequence result. Cool. Okay, so this works. All right, so we can say points 5. Let's just say the 5. The points is 5. So this is a single value. So then we can just say s dot easing equals ease dot linear. Snap. 0 should be fine there. We can say s dot easing or s dot values end dot format float parse float. No dot content no dot value. Okay, and then we can set it. So we have 5, an easing value, and a snap. But if we say, oh, points should be like this, then we have a content key. Oh, that's, what is the value is here. Otherwise, the value is here. Otherwise, the values are. Otherwise, it's a map. And then this is the key, and this is the value. These are the values. This is the result. Okay, I think I get it. So there's 3 possibilities. Node.value. Well, I guess if node.value is blank, is not blank, then that means that we can use the value. Otherwise, if node kind style document a mapping a sequence. Well, I guess we just switch off of that. So if node dot kind scale it. Could have just done this to begin with. I'm gonna take a look at this again to see how this exactly works. So we had a map. We have, is this, I think it's k value, right? So then we say easing, k value, yeah, okay. So now we can do that like this. result or value. All right, so content key. Okay, so key is going to be values. Okay, so case values. S dot. Like that. Easing. Let's see here. As that easing equals func. Okay, so I think that should do it. I think that should do it. All right, so now we have values of 5, 10, 15. Easing is set to something. Let's set it to in-out bounce. It's different. Okay, perfect. If we don't set easing, it should go back to linear. Perfect. Let's set snap to be like 4. That's 400. Okay, perfect. Cool. All right, so that's that. Now the good thing about this is that we only have to do this once because all of these things work kind of the same. So points works like this. Position should work like this. Essentially, it would be better if they were vectors. No, I'm gonna leave X and Y. I'm gonna leave X and Y in width and height like this. Okay. Why does it look so weird? Y is orange for some reason. I'm not sure why. That's weird. I'm not sure why Y is orange. Okay, so that should do it for those elements. Rotation is similar. Rotation. Okay. points is specifically for things that use that number. Okay. This is shaping up. It's shaping up. This is shaping up to be pretty simple. Like I'm kind of liking how simple it is. Well, then why do I even? Because it's pairs, right? Because these are pairs. You're dealing with pairs. Never have a single. No, you could. I gotta think about this some more, but I think I'm on the right track. Because once I have this working like this, that's why with the height. Possible. Okay, I'm just like it's so much thinking, dude. It's so much thinking. It's so much just like consideration. Okay, I'm gonna take a break. I'm gonna go finish here, but I think I'm making a lot of progress. A lot of this is just restructuring the code so that it works more consistently, because it's like I don't want to make it, trash. I don't want to make it kind of garbage. I want to make it so that it works correctly and it looks good and it fits good. The code works well, everything. I think this is better. I think this is a lot better. Did some reading on Go.js as well to see like what they offered and how they did it, so I can kind of get a general idea of the kinds of things that would be useful to kind of replicate those effects. And so far, I think I have everything I need, or not everything I need, but I have a general idea of how to implement some of the things or most of the things that I'll need. Yeah, so this I'm just like restructuring the code. Once it works, once I have everything working, the hardest part is not the hardest part, but just the most annoying part is going to be basically making it so that if no, I can't do that. Basically, what I would want to do is make it so that if you go from one shape to another, like if you say like have this shape start here and move down, then like move to the right. I want to be able to just type then like this, and then do like X. I mean, maybe you could just do something like that, like X 230, do 400, 450. Because then if you did it like this, then well, yeah, it still wouldn't quite work. But the idea is that basically I want some sort of method to animate things additively, so you don't have to like type it in manually. So if you have a shape that goes like, let's say it starts up here and it goes down and then it goes right and then it goes up, I want to be able to type those in with just like basically one line animations where we say like y goes from 0, let's say it starts at 0, or let's say it starts at negative 200, it goes from negative 200 to 200, and then x goes from where it is to 400, and then y goes from where it is to negative 200. I don't want to have to keep track of like the starting position. So doing something like this, 232, that kind of makes sense. The alternative would have to be something like this, where the first entry is blank, and that apparently is bad. Yeah. So yeah, maybe something like that. 232 to 200 would be good, because then I can detect that it's a string, detect that the word 2 is in there, and then basically say like, oh, you want to go from the last value to the next value. So then maybe what I need to do is just basically keep track of the last value. Well, that's what I was doing. The kind of problem comes in because I guess that's true. Maybe I could do it that way. So maybe a shape like reads the values from the shape definition, but it doesn't actually modify. Yeah, okay, that makes more sense. So the shape that's animating on screen is reading the shape definition, but it's not modifying the values in that shape definition. It's basically copying the information from that shape definition and then inputting it into its own shape definition, into its own shape. Then when the shape definition changes, because it is going to a different animation state, it refocuses to the next one, but then it just keeps going from there. No, I don't think that'll work. But the general, I'm on the right track though. I'm right here. I'm right here. Because once this works, once I get the kind of fundamental design down, I will see about implementing a transform system so that you can parent things and rotate things and have things rotate along with them. I mean, like, there's things that I need to do, but once it works, brother, it's gonna be insane. It's gonna be insane. It's gonna be insane. You won't even believe it. It's gonna be crazy. I think it's gonna be crazy. I think it's gonna be crazy. Dotted lines. There's so much. I'm my brain is like surging with information, but I gotta take a break. I can't just power through here, because this is something that's gonna take hours. It's gonna take like maybe 5 more hours for me to get to like a solid state. The transform system, I'm not sure how I'm gonna do that yet. I'll need some kind of node that basically has like a position, which is a vector, and a size, and a rotation for that matter, which can just be a float 64 because it can't rotate in any other direction than one direction. Yeah. Size would probably be best off if it was just like if it started off as 1, right? Like that. Yeah, something like that. Something like this. And then once I get this transform system to work, it would be like let's see. It would have to be, I mean, I don't even know what the transform would return. It would have to be a matrix, right? It would have to be something that you could use to transform vectors, because that's how we're defining the lines for rendering things. So something to transform vectors. Also, I have to figure out what I'm going to do for size. I'm thinking like it would be good to not have any pixels by definition in this, but if I mean, how else, like how else am I going to do it? Like what, you have to have some sort of definition of something. That then kind of looks good. I like that. Maybe a motion too. Like that. Like that sign, because then you can have a wave. Okay. It's been real. So much of this is just thinking and planning and consideration, and I guess I'm gonna hold on. Let me. You should be able to make a 2D thing for a 3D. Like for 3D math, I made a 4x4 matrix. If it's 2D math, you can just do with a 3x3 matrix, right? I'm thinking that you could just do with a 2x3, because you have position on the right hand side, and then the central square is for rotation and skew. Or was it a flipped? That. 2, 2, 3. 1, 2. I think 2, 3 is 3, 2 rows of 3 like that, which is I think what I need. I think that's right. I'll have to look up some 2D matrix stuff. Let me see. Let me just look it up real quick. Two D transformations. Yeah. Matrix multiplication. And translations. So it's a 3x3 matrix. It's a 3x3 matrix. Okay. Okay, so it's 1 all the way across. Oh, here you can see. So translate X and Y is these two, no change. This is the unit scale about origin, rotate about origin, shear, reflect about origin, reflect. Okay, cool. So that's scale. -1, that's flipped. Yeah, composition. Okay, cool. All right, well, that's pretty simple. We could do this pretty easily. That's our unit matrix, which I guess means that we should probably return matrix dot unit. Translate 4. 0, 1, 2. Okay. I don't know if this is. Let me take a look to see which. I think I have it reversed from Tetra 3D. Let's see. Translate 3. Okay. 3, 0, 1, 2, 3. Okay, yeah. So we want to do it the same way. I'm making it more complicated for no reason. Look at me. Scale is 0, 0, and 1, 1. Okay. Okay, something like that. So PRS. Let's see. Okay, so I think this is right. And then we just need a function to multiply a vector. Let's see. X plus TX. Oh, is it just... This is T plus TX is after the rotation. X times cosine delta minus Y sine. So this times this minus this times this. Okay. No idea if I'm gonna be able to do this correctly. It is... Let's transform. I could probably just crib my code from Resolve, from Tetra 3D actually. Let's just we just multiply it? Oh. Okay. We don't have M3. That might be it. We'll see. Translate, scale, rotate, shear. Okay, that might give us enough to work with to begin with. Okay, so this is a good start. I should be able to use this to kind of get things going. Why don't I just do like this? Yeah, there we go. That's better. All right, so we have to clear a matrix. We don't have to clear a new matrix. That's unit by default. Cool. All right, yeah, this is fine by default for now. We will come back to this later, and I'll see what on earth I'm doing. It will be fun. Yeah. So yeah, thank you very much for watching. I've been SolarLoon. It's been real. I'll catch you guys on the flip side next time, and we'll see how this ends up turning out. This is interesting. But yeah, thank you very much for watching. I'll see you later. Bye. Oh, if you want to support development, please check out Patreon, patreon.com/SolarLoon. Please check out Masterplan on itch.io or Steam. And yeah, thanks for watching. All right, see ya. Bye.